Okay, so I'm actually gonna break up 6-5 into two parts. Okay, so we're gonna get farther than I did with first period, but just so you know. Okay, so we're gonna start with something that you've already know how to do. Yesterday, when we took the square root of a number, or we took a cube root or the fourth root, it came out perfect, right? Like I gave you 27 and it came out to be 3. Today, the numbers aren't gonna come out perfect and neither are your variables. So we're just gonna start with example 1. So operations with radical expressions deal with simplifying them, adding, subtracting, multiplying, and dividing. Today, I'm hoping to get addition, not adding, multiplication and simplifying. And then tomorrow, we'll do adding and dividing. Okay? So, here we go. So this is a simplifying one. Okay, so we're going to simplify the square root of 540. So if you looked at your chart, you would know that 540 is not on it. Now there are some calculators that will simplify this for you. On the test, you will not be able to use that type of calculator, okay? So you have to know how to do this. So on 540, what are two numbers you can multiply together to get 540? Any two numbers?
54 and 10.
54 and 10. I like it. Okay. Now, are either one of those prime numbers? That means they only have two factors, one in itself. Okay, so what are two numbers you can multiply to get 54?
27 and 2.
Okay. You guys, first period asked me why I always do, if there's a way that you have to do it. No, I always write my numbers from least to greatest. I don't know why. It's just a habit I've gotten into. You could have written that 27 times 2. You'll still get the same answer. What are two numbers? So why did I circle 2? Because it's a prime number. Okay. What are two numbers you can multiply to get 27?
9 and
3. Okay. Any of those prime?
3.
Okay. What are two numbers you can multiply to get 9?
3 and 3.
Okay, now we're going to go back to 10. What are two numbers you can multiply to get 10?
5 and 2.
Okay. Now, when we go to simplify, we're only going to worry about the numbers we circled. Anything else is irrelevant. The only numbers that matter are the ones that you circled because those are prime numbers. Now, let's look for pairs, okay? Do you have a pair of 2s?
Yes.
Okay, so I have a pair of 2s, so I'm going to write that on the outside. Do I have a pair of anything else?
3s.
I have a pair of 3s. And you notice that when I say I have a pair, I cross them out. That means I've used them. So it means they're never going to show up in the problem again, okay? Now, so I cut out that pair of 2s, I cut out that pair of 3s. What about this 3? Does this have a pair?
Nope.
So that's going to go inside. And what about the 5? Does that have a pair? So that goes on the inside as well. Now, 2 times 3 is 6, so that's my number on the outside. And 3 times 5 is 15, that's my number on the inside. You guys, the reason we take pairs is because when you take the square root of something, right, you always want a pair of the same number. Like the square root of 4 is 2 times 2. The square root of 9 is 3 times 3. So everything comes in pairs when you're taking a square root. If you're looking at a cube root, then you would do everything in 3s. Okay, are there any questions over that one? Okay. So we're going to take the square root of 12c to the 5th. I'm hoping that we can get down to what happens when we have cube roots or fourth roots, okay? But I want to start with this. Okay. You see one problem. I see two problems, okay? And I don't mean problems as, I mean like two problems that we have to work on. So I have the square root of 12, and I have the square root of c to the 5th, okay? That's what I mean by two problems. So we're going to have to simplify the square root of 12, and then we're going to have to simplify the square root of c to the 5th. The reason that this is different from yesterday is because 5 is not divisible by 2. Like when you go 5 divided by 2, you get a decimal. You can't have decimal exponents, okay? So let's start with 12. What are two numbers you can multiply to get 12?
3 and 4.
Okay. If you thought of 2 and 6, you can use that one as well. You do not have to start with the 2 that I gave you. If you thought of 2 and 6. Okay, what are two numbers you can multiply to get 4?
2 times 2.
Okay. What do I have a pair of? Okay. So that's going to be 2 square roots of what? So you guys, I crossed out the 2. That's why I put it in front. The 3 was left over. That's why it's in the radical. Now, when you go to simplify variables and the exponent, like you have an even index and it doesn't go in evenly, the nice thing about variables with the 2 is you just break it down to c to the 4th. You just bring it down 1 times the square root of c. So the square root of c to the 4th times the square root of c. So I just broke it down. Instead of 5, I did it 4 and 1. Now what is the square root of c to the 4th?
C is thing.
C to the thing? Second. There we go. C to the second power. Because 4 divided by 2 is 2. Okay? So this is what we did yesterday. Yesterday we did 4 divided by 2 and got c squared. Today I'm adding something else. So now our final answer is, what is on the outside? Now we're going to combine the two. What's on the outside of the square root? 2 and c squared, so that's going to stay on the outside. And then what is left in the square root? 3 and c, so that goes on the inside, and that's your answer. So you guys, a lot of times when we do these problems, kids look at it and they're like, I don't even know where to start. Break it up. Break what's ever underneath the square root sign into parts, okay? So I shouldn't say problems. We have 2 parts to this problem. And it's okay. You don't have to, anytime, break things up into parts for you. Okay, you ready for example 3? Sure, Miss Fleury, we don't care. Okay. So we have the square root of 128 d to the 7th e to the 11th. So how many parts of this problem do I see? 3. There's a number and there's 2 variables. 3 parts. Because I truly believe that if you break it up and you don't just do, you don't try to do it all at once, I think that it goes a little bit easier. Okay, so we need two numbers that you can multiply to get 28. Well, I'm not 28, 128.
16 and 8.
16 and 8. Did anyone think of two different numbers? Did anyone think of a number?
No.
If you thought of 2 and 64, go with that because you guys can work. I'm going to do 16 times 8. What are two numbers you can multiply to get 16? What are two numbers you can multiply to get 4?
2.
Okay, what are two numbers you can multiply to get 8? You guys, you notice I circle 2s, I circle 3s, I circle 5s, I'll circle 7s. Those are because those are prime numbers. I crammed this into this little spot. I shouldn't have. Okay, I see a lot of 2s, right? Do you guys see a lot of 2s? Okay, so what do I have a pair of? Let's see. How many pairs of 2s do I have? 1, 2, 3. So that means it's going to be 2 times 2 times 2 times the square root of 2. You guys, there's 1 pair, 2 pairs, 3 pair, and then this 2 is left over. That's why it's in the square root. So this becomes 8 square roots of 2. Okay, now how am I going to do d to the 7th? What do we break that up into? Say it louder. The square root of d to the 6th, because we're going to go down 1 lower, times the square root of d. You guys, whenever your index is 2, the square root, whenever the index is 2, all you have to do is take the odd exponent, drop it down 1, and then then another letter. Then the other letter will go in a square root. Okay, so now what do we're going to ignore this for a second. What do we do with the 6 and the index? What did we do yesterday? Divide. So 6 divided by 2 is 3. So that was an even divided by an even, and we got an odd. What do we know? Absolute value. Okay, now let's do e to the 11th. Oh, so that you guys, it would be the absolute value of d to the 3rd to d. I'm sorry, I don't know why I crammed this in. Okay, now what does this become? Square root of e to the 10th times the square root of e. And then what happens with, so 10 divided by 2 is 5. Anytime you look at you're like, oh, I got an odd, look at what you divided. Even, you have an even exponent, you have an even index, you ended up with an odd exponent. So what do I need to put around that? Absolute value. And then we're left with the square root of e. So let's put everything together now. What's on the outside? Our number goes first, which is, then we have this. Then I have this. You guys, you don't have to put each letter in its own individual absolute value. Since everything is in the absolute value for those, you can put them both in there. If you only have 1, then you only would have that 1 in absolute value. And then what is left inside the square root? 2 d e. Okay. There any questions over what I did there? Anybody wondering how I got the answer, where I got the 8, where I got the absolute values, or why I got the absolute values, and how I got the 2, D, and E? Can I take it away? Okay. Here's example 4. Okay, so in this problem, we have 3 parts again, okay? So I have the cube root of 27, I have the cube root of y to the 12th, and I have the cube root of 7z. 27 is a perfect cube, and that gives me 3. So there's nothing else again. So again, you guys, 27 is a perfect cube. 12 divided by 3, that is perfect. So that is going to be y to the 4th, 12 divided by 3. But z to the 7th, 7 divided by 3 does not work. So I'm going to break it up so that there's an exponent that is a multiple of 3. So I've got 3, 6. Oh, that's good. That doesn't go over 7. So I'm going to do the cube root of 7 to the 6th times the cube root of z. I'm sorry, z to the 6th times z. Okay, so now 6 divided by 3 is 2, and I'm left with this. Now, I know that you guys could do it in your head, like especially these parts, but I just wanted to show you. So our final answer is 3 y to the 4th, z to the 2nd, 3, the cube root of 3, the cube root of z. Okay, so the 3 went on the outside, y to the 4th went on the outside, z squared went on the outside, and then this was left. I want to do one more example with you, just to show you what happens when you multiply, okay? Okay, so I have 10, the cube root of 100 a squared times 4 cube root of 10 to the 10a. Okay, you guys, even if these were squared, you're going to do the same thing. These match, so now we're going to multiply the outside numbers. So 10 times 4 is 40. Okay, you're going to put the 3 here. 100 times 10 is 1,000. And then 2a squared times a is a to the 3rd. So now what we need to do is determine if 1,000 is a perfect cube. So I have 40. The cube root of 1,000 is indeed 10. And that's on your power sheet. 3 divided by 3 is a. So my final answer is 400a. So that should be like problem 5 on your homework. Again, you guys, even if this was squared, you would have done the same thing. 10 times 4 is 40. 100 times 10 is 1,000. A squared times a is a to the 3rd. The index matches, so you can do that. So 40 just comes down. The cube root of 1,000 is 10. The cube root of a to the 3rd is a, and then I just multiply that all out, and that gives you the answer. Thank you, and good luck on your homework, you guys.